right, time to pull it all together. We're going to solve some equations. You have to be kind of quick on your feet for some of these, but I'll give you some strategies to use. Just a reminder, if you have the same base and the two sides are equal, then the exponents are equal. If you have the same logs of the same base and both sides are equal, then we get both of those arguments are going to be equal. All right, so we have this equation here. First things first is to isolate the tricky part. So I want to isolate the base where the exponent is the variable. So I want to get rid of that 20, in other words. Divide both sides by 20. And that leaves us with 1/2 x to the third equals 1/4. Notice I kept that as a fraction. It's going to be helpful. This is where you have to be kind of sharp, quick on your feet. There's a relationship between 1/2 and 1/4. It's not just kind of like a multiply by 2. But if I square 1/2, I get 1/4. So in other words, 1/2 to the x over 3 is the same thing, is equal to 1/2 squared. So that's where that 1-to-1 property comes in. Because I have the same base, both sides are equal. I have two different exponents. This one's x over 3 and this one's 2. But in that case, it just means that x equals 6 when I solve that much easier problem. Okay, next up, here we have a couple of different logs, all kind of spread out. So let's see if we can simplify by combining our logs. So we have this addition in the middle. Oops, sorry. Addition in the middle. And so I can take the natural log of 3x minus 2. I'm going to put another set of parentheses in here. And I can multiply it by x minus 1. Because if I have two logs, same base, being added together, I can combine them into multiplication. Simplifying the other side, if 2 is the coefficient, this is the natural log of x squared. And we're going to need to FOIL our left-hand side, so stick with it and press pause, try it on your own. Okay, so now we have the natural log of this trinomial, and we have the natural log of x squared, so I can set the two equal to each other. And then move everything to the same side, so that I can factor, because if I see an x squared, I should always look to see if I can factor. So, in factored form, we get 2x minus 1 times x plus 2 equals 0. Solving for x in both of those, we get x equals 1/2 or 2. However, one of those, if we plug it in, so starting off with a 1/2, if I put a 1/2 in here, we get 3/2 minus 2. So that actually gives us negative 0.5. All right, so let's think about that. The natural log, so that question asks us e raised to what power gives us a negative number? Well, e is positive, and there's nothing I can raise a positive number to, no exponent, that gives me a negative answer. So we actually have an extraneous solution where x cannot equal negative 1/2 because I would get an error, a non-real answer. 2 works because 6 minus 2 is positive, 2 minus 1 is positive, so everything works out. Now x is only actually 2 here. Okay, I want you to try this one on your own. Give it a shot. Okay, so this one's going to take a little bit of a trick here. You could actually solve this one graphically by putting in this for y1 and 0 for y2. But let me show you the trick for doing it algebraically. I have e to the 4x minus 2e to the 2x minus 3. Alright, so I have an exponent that's being multiplied by a number, so 4x. That can be rewritten as e to the x, and then all of that raised to the fourth. And this one could be e to the 2, and then it could be x, and then all of this is squared. That's not immediately helpful, so I'm going to take it one step further. Basically what I'm trying to do is make this look more quadratic. You start to learn just, okay, this is something I'm going to try to make look quadratic. Alright, so instead of e to the x to the fourth, let's do e to the 2x and square it, because we would still multiply by 2, minus 2 times e to the 2x. Well, that's nicer because both of those have the same exponent, and the first one's squared. That doesn't change. So if I do a quick substitution here, let's call e to the 2x, we'll call that w. When I've rewritten it like this, I get w squared minus 2w minus 3. And that's easier to factor. We just need two numbers that multiply to negative 3 and add up to negative 2. So we get w plus 1, w minus 3. And then we would plug in the e to the 2x back. And set both of them equal to 0. There it is, wrapped up. So then we would solve for e in both of those. And I'm sorry, solving for x in both of those. So we get e to the 2x equals negative 1, and e to the 2x equals 3. Basically, I can go ahead and tell that the first one's not going to work. E raised to any power is not going to give me a negative, so that one's extraneous. E to the 2x equals 3. Take the natural log of both sides. And we get 2x equals 3. So we get x equals 3 over 2. That one is tricky, and I'm be happy to walk you through it again. Just make sure you've written down everything. I know I had to kind of start over to give myself some more room. But again, you could do it graphically, put everything on the left into y1, put 0 in for y2, and look for the intercept. Okay, so this one is solving a logistic equation for x. We're going to try to get the e to the x part by itself. I'm going to multiply both sides by the denominator. I mean, actually, what I'm really doing is I'm going to switch this. Okay, so I'm going to try to get the e to the x part by itself. So I'm going to multiply everything by the denominator, so that I'm going to get 400 is equal to 150. I'm not going to distribute, times 1 plus 95 e negative 0.6x. Okay. Then isolate the stuff in the parentheses. And from there, so quickly, once you start doing the algebra, you're going to get down to 1.667 equals 95 times e to the negative 0.6x. I'm going to need to erase and give myself some more room, so copy that down. Divide both sides by 95 to get the e part by itself. Then take the natural log of both sides. So we get negative 3.57 equals negative 0.6x, and then solve for x. And we get x equals 5.96. The same old way that we solved it before still works. Put everything on the left in as y1, put 150 in for y2, adjust your window, find the intersection, and then you get your answer that way too. Okay, try this guy on your own. Let's see how you do on that, and then we'll go over the answers in class. Let me know if you have any other questions. Make sure you're copying down all the examples so that you have something to look at.